Hello everyone, welcome to my channel My Tech Notes. So today in this video we'll talk about functional programming. We'll see what is functional programming, how is it different from object oriented programming, and what all new features are available in functional programming. Please click on the like button if you like this video. Also subscribe to my channel and click on the bell icon to get notifications whenever I post, so that you can get notified whenever I post a new video. You can also tell me in the comment box on which topic you want me to make a video for you. Okay, so now let's get started without any delay. So first of all, what is functional programming? So functional programming is a way of programming that follows a declarative programming model. It was introduced in Java 8 with lambda expressions. Okay, and this is a programming model that follows a declarative programming model. It tells compiler what to do but not how to do. Functional programming, as I already told you, it is introduced by Java 8. I will share new features introduced by Java 8 in upcoming videos. Okay, so coming back to functional programming, how is it different from object oriented programming? Functional programming follows declarative programming model, while object oriented programming follows imperative programming model. Okay, so now what is declarative and what is imperative? Declarative programming model is where we execute a function as a mathematical expression. Okay, while in imperative model we write separate lines of code to execute a function, to call it, and return statements from it. Okay, while in case of declarative, we don't need to explicitly implement a function. Okay, so I can show you some examples for it so that you can get an idea about it. So here, see here, this is an example of a declarative programming model, very basic example. So here declare.java is a class. In that I have defined interface addable, and that interface has a method that is called add int a int b, right? We have not done any defined any implementation of this method. Okay, you cannot find it in this code, right? So now here is a class declare. Inside the public static void main, I want to call this add method, right? Okay, so how I did that, I created an instance of addable interface, addable ad1 equal to, now here is a one method that is use, that is add with int a int b, right? So here we are just passing two parameters, x and y, and return will be x plus y. Okay, so when we want to print so that's how we have passed the parameters, and this here is we have defined its function, like x and y will be the input arguments, and x plus y will be the return output from this function. We don't need to write separate lines of code for it, okay, like we used to do in object oriented programming. And now under sysout we are writing add1 dot add 1020. So here we have defined what this function is going to do. So okay, so this is just one line of implementation for this function add, and here we have called this function and passed the parameters inside it, right? 1020. Now if we execute it, so here is the output, that is 30, right? Now if you want to see imperative model, that is being followed by object oriented programming, so here is the imperative. So same, here I have an interface addable1. Inside that I have defined a method that is add int x int y. Since it's an interface, okay, so as per imperative model we have to implement this interface explicitly. So here we are implementing this interface addable1 inside public static void main. Okay, we have, if we are implementing this interface, we should also provide implementation to the method add, right? So here is the implementation of the method add. Okay, in declare model we have done it in a single line here, right? X y arrow x plus y, while in imperative model we have to write separate lines of code for that. So here is an explicit implementation of the method, and so we'll have to pass two parameters x and y, and it will return value as x plus y, right? And inside public static void main we have created an instance of interface, that is addable one, add new imperative, and sysout add one dot add 10 20. So if we execute it, it will also return 30, but see, here is a separate line of code, separate line of effort, right? While in case of declare, we have defined the method implementation only in one line, and we are calling it here. We don't need to explicitly implement this interface. Okay, so this interface is called functional interface, and this expression is called lambda expression, that we will see in upcoming videos for Java 8. Okay, so here I am just giving you a heads up that this kind of interface that has only one abstract method is called functional interface, and this interface is also called single abstract method interface. And this way of calling a function with this implementation is called lambda expression. Okay, we'll see it in detail in upcoming videos, and I have some more examples to show you for this. So let's move further. So this is what, so functional programming follows declarative programming model, while object oriented programming follows imperative programming model. In functional programming we have to write less lines of code as compared to object oriented programming. In functional programming we are just telling the compiler what to do, we are not telling how to do it, right? While in imperative we have to tell, like, okay, this is the statement you should execute, after that execute this statement, the next statement. So it has to follow a sequence of statements, while that's not the case in functional programming. So these are the difference between functional programming and object oriented programming. So what to do versus how to do. So functional programming tells us what to do, it never tells us how to do. It never gives us steps to execute to perform any action, right? While it just tells us that if these are the input arguments, so this should be the output value, that's it. Next is referential transparency. It's one of the most important feature of functional programming, that it comes up, it provides us referential transparency. Whenever a function is called referential transparent if it always return same result value whenever it is called with the same arguments. Okay, it never change the state of an object or a any variable. Okay, so that is what referential transparency means. The function should be pure function and immutable. It should not change the state of its member variables. So that's what is called pure function, that is what we call immutable, and that is what we call referential transparency. A pure function is always referential transparent expression because it never changes the state of an variable or argument that we are passing to it. Okay, it always returns the same output whenever we pass same argument. Okay, so here is an example of referential transparency. So here's an example of pure function. See, object with pure function, public int sum int a int b and return ab. Okay, so it is a simple method that is accepting two arguments, int a and int b, and returning a plus b. So it is not changing any state, it is not changing any state of a input variable or any object inside it, right? While here you can see a non-pure function that changes the state of variable passed to it. Okay, so here is a method public int add int next value. So we have defined a local variable, that is value. It is changing the state, sorry, not local, global variable, that is value equal to 0. So it is adding next value inside the value. So we are changing state of value, global variable, right, and returning this dot value. So this is called non-pure function, this is called pure function. So pure function is always referential referential transparent because it always returns the same output with the same arguments. Okay, while in this case of non-pure functions, the output can change or input argument values can also change because it changes the state of the variables. So this is called referential transparency. So referential transparent programs are easier to understand, easy to develop and independent. That's why it is preferred in functional programming. Okay, next is mutable and immutable data. So functional programming supports immutability. That means state of a variable object does not change. While in object-oriented programming model that follows imperative programming, it is mutable. That means it can change the state of an object or a global variable, local variable, while performing some functions, operations inside a function. Calling same function multiple times with same parameter might change the return value. So that is possible in object-oriented programming. While in functional programming, since it supports referential transparency, it supports immutability, it does not change the state of an instance variable. Okay, we have seen it in this example. So a function in functional programming or declarative programming model should always be pure. Alright, now coming to next slide. Supports. So functional programming supports parallel programming, while object-oriented programming does not support that. So what do you mean by parallel programming? Parallel programming is a way to take full advantage of multiprocessing system. In parallel programming, each task is a discrete unit of a large task, or you can say each task is a small unit of a large task. You can say that a task is breakdown into multiple subtasks. Each task is independent and their execution order does not matter. The tasks are defined according to the function they perform or data used in processing. Okay, so this is called parallel programming. So there are two kinds of parallel programming, that is functional parallelism and data parallelism. Where do we use parallel programming? So parallel programming is very much useful for a larger problems where we can split a problem into small subtasks and execute them all together without impacting each other. Okay, each other execution. As a result, when the tasks are distributed among processors, they can obtain the result faster in parallel programming. We use parallel programming to resolve larger problems that does not fit into a single CPU architecture or that cannot be solved in a reasonable amount of time. So there parallel programming is a must in functional programming. Okay. Next, execution. In functional programming, the execution of statements can happen in any order, while in object-oriented, it has to follow a sequence of statements. Functional programming supports parallel programming, so it does not care about execution of tasks. Okay, so that's why functional programming is relatively faster than object-oriented programming because it does not follow an execution order. So this is the difference between functional programming and object-oriented programming, and this also show you how functional programming is better than object-oriented programming and where we can use it. As we say in the last slide, that functional programming, since it supports parallel programming, so it can be used for larger programs or for the larger problems that might take larger time to get resolved. Okay, next is iteration. So functional programming follows recursion for iterative data, while object-oriented programming use loops for traversing the data. So what is recursion in functional programming? Recursion is called when a function calls itself directly or indirectly. Okay, and the function calling itself is a recursive function. It is mainly used when the solution to bigger problem can be expressed in terms of smaller problems. Okay, so here is an example of small example of recursion, like test.stream, filter, temp, num. Okay, so here it is calling it by itself. Okay, so we don't need to define any loop outside here. Like in iteration in ops, we have defined a loop, like so for temp t test, so it will go element by element and print that element. While in case of recursion, here we have a function, inbuilt function, test.stream function. Okay, and we on that we have applied a filter, on that we have applied a for each. Okay, so this for each function is calling itself for each of the parameter, or each of the element in the array. So recursion and iteration are both different. These are two different ways to execute a set of data, right, or to execute a set of instructions repeatedly. The main difference between recursion and iteration is that in recursion we use function calls to execute statements repeatedly inside the function body, while in iteration we use for and while loop to do the same. Okay, so iteration is faster and more space sufficient than recursion. Why do we use recursion in functional programming? Because it is easier to code a recursive approach for a given problem. Elements, type of elements in functional programming are variable and functions, while type of element in object-oriented programming are objects and methods. Use. So functional programming is preferred when there are few things to do, but there are many operations in our program. Okay, while object-oriented programming is preferred when there are more things to do, but with less number of operations. Okay, so by more things to do means you have more number of statements to execute. Okay, so that is what that's the difference between usage of object-oriented programming and functional programming. We still use object-oriented programming, but there are different scenarios to use both of them. So both have separate space in Java. Okay, so this is it for now for the functional programming. Thanks for watching this video. In my next video I'll cover all the new features introduced in Java 8. Until then, keep studying. Bye.